Okay, awesome. So our first session is about number theory. So has anyone heard of what number theory is? Feel free to type in chat if you have any ideas or message me privately, something like that. Oh, we have one thumbs up. That's really good. Okay, awesome. So today we're just going to go over the foundations of number theory because it has a lot of really important applications. So I think that it's one of the fundamentals of pursuing maths Olympiad. So we should definitely look at it. What we're going to go through today, I'll just do a quick intro and we'll briefly talk about, oh, one more person has arrived. Hi, Julie. So what is number theory? And then third, we'll talk through a few number theory concepts. So that would be remainders and division, modular arithmetic, prime factorization, greatest common divisor, and lowest common multiple, alongside some other properties of modular arithmetic. Okay, so just a very brief intro. Hi guys, if you haven't already met me from the introductory section, from the session, I'm Nicole and I'll be your tutor for the next 2 weeks. For this week, we'll be going through number theory and then the week after, we'll be doing geometry. So feel free to contact me. You guys already know the email address, mindnz.org@gmail.com, but feel free to also contact me through my personal email address as well. Okay, so just for people who weren't able to make it to the introductory session, I'll just quickly walk through how classes will run. So before class, you will receive an email from your instructors with the course content and handout for the session. So hopefully everyone has received the handout for today. Can you guys give me a thumbs up if you got the handout, which is just a PDF with a bit of information on it that I sent out? Okay, yeah, I'm getting some thumbs up. Okay, I'm gonna assume that everyone's got it, but if anyone hasn't, feel free to let me know and then I'll send it through to you. Okay, awesome. And then the handouts will have a couple of problems for you to attempt within your own time. I've only put a few today since we're learning more foundations, but I think that it's if you already are familiar with some of the content, you can go ahead and try doing it. And if not, we can walk through them later. And every week there will be a 20-minute workshop, so it's kind of optional. You can pop in if you need to ask any questions, if you want some individual help, things like that. So we will send out those slots very soon. Rules, they're pretty normal ones. Just, avoid interrupting the instructor. You can use the hands up button if you have any questions, if you want to unmute yourself. Just the general things, be respectful towards everyone, inappropriate language. And it would also be pretty good if you could turn on all of your cameras to make the class more interactive. I think that does help, at least for me, so maybe you guys can all try it out as well. And then I would prefer that you guys all have your name as your real name. Oh, good job, everyone. Lovely faces. So you guys can change your name to your real name if it's possible so that we can tick off the roll. Cool. Okay. And then, of course, another recap. We're really big on making sure that everyone can keep up. So we will be recording this and putting video recordings of the classes onto a YouTube channel. And so you can check our website for that. And then you can also join our Discord servers. If anyone has any problems with it, feel free to email us and then we can try to help you sort that out. Okay, so what is number theory? Does anyone want to tell me or should I just get into it? Okay, all good. Well, number theory is honestly a huge field of mathematics. And this is what this famous mathematician called Gauss said. He said, mathematics is the queen of science of the sciences, and number theory is the queen of mathematics. So number theory is something that I think we have all actually dealt with before, even if we don't know the name for it. because number theory is essentially the area of mathematics that deals with the integers, right? So these are like, the numbers that we've seen so many times, just like 1, 2, 3, 4, and all of the numbers I've listed here are all integers. So in number theory, we kind of discuss the very interesting relationships between these numbers and their properties. Okay, so to kind of exemplify what I mean by these interesting properties and relationships, we'll talk through some number theory concepts. So it's going to be fairly foundational for now, so let me know if anyone wants some extension or wants me to slow down or anything like that, because there will be some new terms that we might have not encountered before. Okay, so has anyone kind of like seen remainders in division before? I would assume so, right? Can I have a big thumbs up? Awesome. So I feel like we might not have to go through it too much, but I'll just make sure that we are all familiar. So, right, the remainder, of course, is just like what's left when you divide a number by another number. So someone tell me, what's the remainder of 47 when divided by 8? Yeah, good job, Jason. Good job. Nice, very nice. And then can I have someone else tell me what's the remainder of 35 when divided by 4? Okay, awesome, Ellie. Okay, so I think everyone has basically got this. That's really good. So this is just something that we need to make sure that everyone knows before we kind of piece it all together to get to what modular arithmetic is. Yes, good job, Jenny. Was that Jenny? I think so. Yeah, guys, I'm on like 2 accounts right now, so it's a little confusing, but all good, making it work. So, modular arithmetic. This is where we get a bit more technical, but I think that it's not too hard to understand because we kind of already have this kind of fundamental knowledge that is required to understand this. So, modular arithmetic concerns the properties of numbers as they wrap around given a certain number, or a modulus. So, wrap around is not that, it's a bit hard to understand, but let's just define some equivalent statements. So when you say A is divisible by B, that's the same thing as the second line where we have this notation B, and then you have like this horizontal, this vertical line A. So that just means that A is divisible by B. Right, and of course it's equivalent to saying, oh, we have one more person joining. Okay, it's also equivalent to saying that the remainder when A is divided by B is 0. Does that make sense to everyone? Okay, awesome. Now the third line is what's really common notation in modular arithmetic. So in this case, the modulus is what we mean by B, right? When you have mod B, the modulus will be B. So what that means is that B, or the modulus, is the thing that you're kind of dividing by, right? So on the left-hand side, you have A. In the middle, you have a really interesting sign where you have these 3 lines, these 3 horizontal lines. It's like an equal sign, but with an extra line. Does anyone know what that means? Oh, we got one response. Yeah, it's probably a bit new for some people, but good job. It means congruent. So congruent means that in this, it kind of just says that in this scenario, it's kind of the same. So A, in terms of when in mod B, is the same as 0, because it means you can see that like when you divide by B, the remainder is 0. So then, yeah. For example, 6 is congruent to 0 mod 3 because the remainder when you divide 6 by 3 is 0. and 7 is congruent. Oh, sorry, that should be a congruent sign, not an equal sign. But when 7 is divided by b, you get 3. So that means that 7 is congruent to 3 mod 4. Does that kind of make sense to everyone? Okay, what's the difference between congruent and equal? Well, I think that equal was more like a direct equivalent, right? Because you would say like, 5 equals 5 or something like that. But then like, I guess it's more conventional to use the congruent symbol in modular arithmetic because it's only like equal given like a certain condition, right? In this case, the modulus. Does that kind of make sense? Oh, when 6 is divided by 3, the remainder is 0. Yeah, okay. Does that make sense? Okay, so does everyone kind of understand this notation? Okay, yeah, I understand it's a bit hard to understand, but okay, I'll just share a screen using my iPad, and yeah, I'll just share a screen using my iPad, and then we'll take a closer look at this. Can everyone see my screen? Okay. So we have A is congruent to B for some mod M. Here, we need to note what each of these terms mean. Just checking, can everyone hear me? Okay, awesome. M is the modulus. A is the number that is divided by M. And then B is the remainder of A when divided by M. Does that make a bit more sense as to the notation? The modulus is the number that we are dividing by. So, yeah, it's just a number we're dividing by. So suppose we have A equals to, let's just say 12, okay? And then we want to find what it's congruent to when you take mod 5. So the modulus is, in this case, 5. It's the thing that we're dividing A by. So does anyone know what B would be? Yeah, good job, Jessie. Good job. Is it Suji? Correct me if I got that wrong. Yeah, nice. Okay, good job, you two. Does everyone else kind of understand why this is the case? It's the same as saying that like 12 divided by 5 equals to 2, remainder 2. So essentially the 2 that we get here is the same as B. Is the example the only way, or is there another formula? What do you mean by that? Do you mean in terms of notation? Like, is there another way to write it, or is there another way that we can find B or something? Yeah, I'm not quite sure what that question refers to, but feel free to follow up with me. Okay, so let's just do a couple more examples and then I'll talk about the wrapping around a bit more. So the next one, let's just say, what is 14 congruent? What is B if we have this? If mod is used in any other way, mod is just short for the modulus, so it does refer to the thing that you're dividing by. Okay, guys, good try everyone who's let me know. So, yeah, the answer would be 2 because we just want to think about what is the remainder when 14 is divided by 3. So 14 divided by 3, obviously, like, well, 14 is not a multiple of 3, right? So the nearest thing would be 12. So let's just note that 14 equals to 12 plus 2, which equals to 3 times 4 plus 2. So note that this part is divisible by 3, but then we get here a 2, which is the remainder. And then that's why 14 divided by 3 equals to 4, remainder 2, and therefore 14 is congruent to 2 mod 3. These notes I can upload them onto the website, I reckon. Yeah. If that would be helpful for you guys. Okay, so okay, it's good that everyone's kind of making progress. How about we try a few more examples just to make sure that everyone has this solidified before we move on, because it is pretty important. So let's just say, how about we do 34 is congruent to B in mod 7. And then what does B equal to? Yep, good job, you guys. But we have one more coming in. Has everyone else kind of figured out how it works? Has anyone else got an answer? I think the most straightforward way of approaching this is just by dividing 34 by 7 and then finding the remainder. So yeah, we just want to find like something that like we can try to express it like we did previously with the 14 and do something like that. Like that's how we usually find the remainder when we divide, right? So then we would just go 34 equals to 28 plus 6, which equals to 7 times 4 plus 6. And then that's why we get 6, which is the remainder. Awesome. Do we need one more or is everyone going all right? Okay, sure. We can do another one. Okay, awesome people. Good effort, everyone. We can do maybe 1 or 2 more just to, yeah. Okay, let's do one that's a bit easier. Let's just do 5 is congruent to something in mod 2. Nice, guys. Yeah. Yeah, really good quick maths. Yeah, so the interesting thing about mod 2 is it's essentially, yeah, nice explanation. Right. Yeah. So mod 2 I think is pretty interesting because if you're trying to consider something in mod 2, you're essentially trying to figure out if a number is even or odd, right? If something is congruent to 1 mod 2, then it's going to be odd. And if something is congruent to 0 mod 2, then it's going to be even. Does it make sense why that's true? Because for an odd number, we have 2k plus 1. So then obviously the remainder would be 1 when you divide by 2. And then for an even number, you have 2k. So then the remainder is 0 when you divide by 2. Okay, awesome, guys. Really good. So I think, is that everything? Yeah, I'll stop sharing for now. And then we can go back to the slides. Feel free to let me know if anyone has some other questions. It's like not the easiest thing to grasp, like because the notation is all really new, but good job everyone for your effort. It's going pretty well. And then if we want to talk more about, yeah, a bit later in the session, I'll talk about how exactly they wrap around with some more visuals, and then hopefully we can all kind of understand modular arithmetic a bit better. Okay. Yeah, odd number equals to 1 mod 2. Nice. Okay, so the next thing that we're going to oops. Okay, the next thing that we're going to talk about is prime factorization. Is anyone familiar with this at all? Yeah, okay. So some people are, some people aren't really, so we'll just touch on it pretty quickly. So can anyone just list out the factors of 24 for me? Do we know what factors are, or no? Yes, good job, Crystal. Very good. That was really fast. Guys, you're so fast. That's really good. Okay, so if we're not quite sure what this means, factors are numbers that divide, the factors of 24 would be numbers that divide 24. For example, like we can see in chat, 24 is divisible by 1, divisible by 2, 3, 4, 6, 8, 12, 24. So that's a fair amount of factors. Now, so Julia has said 2 and 3. So that's really interesting because that are those are the prime factors, right? The only prime factors of 24. Does anyone know what a prime is? Yes, good job, Olivia. Does anyone know what a prime is? Can someone explain for me? Okay, yeah, good job, everyone. Thanks for volunteering. Okay, that's really good. So a prime is a number that is only divisible by 1 and itself. And that's really important for when we do prime factorization, because you want to essentially break down a number into its smallest parts that can't be broken down anymore. For example, for the first part of the question, we might say, since we're finding all the factors of 24, let's say that we have a factor of 24, which is 6, because we know that 6 times 4 is 24. But then we think about it a bit more and we're like, 6 can actually be broken down even more, right? Into 2 times 3. But then 2 and 3 cannot be broken down further past themselves and 1. So then those are prime factors. So when we find the prime factorization, we want to count how many times these prime factors occur. So someone in the chat I saw, yeah, it would be 2 to the power of 3 times 3, because when we break 24 down, you get you multiply 2 like 3 times, and then you multiply it once by 3. So I'll share screen again just so we can kind of make sure that everyone kind of understands where we're going with this. Okay, can everyone see my screen? Okay, awesome. So this is kind of the way that I prime factorize sometimes, because I feel like it's just a pretty simple way of making sure you don't miss any of the factors. So what I do is I'd start from 24, and then I would try to break it down by taking the smallest parts first. So I would probably like draw like a tree or something. It's a pretty good way to start if you want, if it's like especially if it's a bigger number, it can be kind of helpful. So then I would take, 24 equals to 2 times 12, then 12 equals to 2 times 6, then 6 equals to 2 times 3, then ultimately you can't break 2 or 3 down more, right? Because they're primes. So then you get that 24 equals to 2 to the power of 3 times 3. Does everyone kind of understand how that works? I went through it really fast, but hopefully it's all right. How about, can you guys try with 36 for me and see what the prime factorization is? Just want to make sure everyone kind of understands this part because it's pretty important. Yeah, good job, Alina. That's looking good. Good job. Oh, Jason, we just want to. Oh, wait. No, that's good as well. Yeah, that's good. Susie. Yeah. So, yeah, we can kind of write it out and wait, Jason. Oh, wait, for 36. Yeah, that's good. And yeah, looking good, everyone. 3 to the power of 2 times 3 to the power of 2 times 2 to the power. Oh, Tara, for that part, do you mean 3 to the power of 2 times 2 to the power of 2? It's looking good, guys. Okay, nice. It looks like everyone has basically got it. Yeah, nice. Okay. So then, of course, we just break it down. 9, and then we get 3, and then 3, and then 36 equals to 2 to the power of 2 times 3 to the power of 2. Yeah, nice, Julia. That's looking good. Okay, so I'm really pleased that everyone has got this part. So let's move back. So yeah, that was really good, guys. It's good that we've, already got this kind of foundation or have picked it up pretty fast. So now we're gonna just quickly work through greatest common divisor and lowest common multiple. So GCD and LCM. Is anyone familiar with this already? Okay, so yeah, I think most people should be quite familiar with it, but once again, I might just stick through it again. What is the just not the okay. So in case you're not sure, just to clarify actually, another way of saying GCD is GCF. So greatest common factor. Yeah, or highest common factor. Thank you, Julia. That's really helpful actually. What's the difference between divisor and factor? Oh, they're the same. Thanks for pointing that out. Yeah, really good. So just know that they're like the same thing. Okay, does anyone need any clarification on okay, I'll just do greatest common divisor. Does anyone need any clarification on lowest common multiple or no? Feel free to private message me or just say it in chat, raise your hand. Because otherwise then I'll just go through greatest common divisor quickly. Okay, awesome, then I'll just go through greatest common divisor. Okay, and you guys can all see my screen, right? Okay, so we'll just go through GCD. So greatest common divisor is like a thing that is derived from when you consider two numbers. So let's just suppose that we want to find the greatest common divisor of how about 6 and 9. Okay, so what we want to do is find the largest factor or divisor that divides both of the numbers. Oh, you already know that? Okay, awesome. Is there one person? It might be someone else who doesn't know greatest common divisor, so I'll just walk through it pretty quickly. I think it's not too hard to grasp, but let's just consider the divisor 6, 1, 2, 3, 6, right? Then 1, 3, 9. And then we just want to find the one that is the highest common one, right? So it's exactly, or the greatest common one. It's exactly what the name says. Yep, good job, Suji. That's exactly right. So you want to find something that is in both of these sets and also the highest one. So of course we get 3 and 3. Can someone tell me what the greatest common divisor of 12 and 5 is? Yeah, good job. It's 1. So let's just note that when GCD of two numbers, A and B, equals to 1, it means that they're co-prime. Co-prime means that they don't have any factors in common. Okay, yeah, that one was maybe not the most expected one, since the highest one is 1, and that isn't very high at all. So let's just try one more. Let's just say what's the greatest common divisor of 16 and 24? Okay, nice. Yeah. Okay, I feel like people have mostly got this concept. Does anyone need me to walk through it again, or is it all right? Okay, seems like it's all right. Feel free, as always, to let me know if you need any more support. So now we're gonna move to, I guess, the harder part where we kind of put everything together. And this is where we're going to talk through the properties of these modular arithmetic things. Okay, so look, it looks not the nicest. Okay, it looks like a little bit, it might be a bit complex, but I think that we can really try to develop our intuitive understandings of this. So these are just some identities that are really important for us to know, and I'll talk more about why these work. So let's just suppose that we have like 4 integers, a, b, c, d, and a positive integer m, which will be a modulus, such that a is congruent to b mod m, and c is congruent to d mod m. So let me explain this a bit more. So this is kind of going back to the initial slide with when we were trying to find the remainder, but there's also a bit more to it, which I will explain now. So if everyone has taken a quick look at this, I will share screen again. Is that fine? Hopefully it's fine. Let me know if you want to go back to that, but it should be in the handout anyways. So yeah, it's good if you guys can look at the handout as well. Okay. So let's suppose that we have these numbers, like I said before. I'll just write it down again. A, B, C, D. Okay, these are all integers. And then we have m, which is going to be the modulus, like we previously defined. Hopefully everyone kind of remembers that, what m was. Yeah, but let me know if you need some clarification. So one really important thing is to consider what congruency necessarily means, because before I was discussing the remainder stuff, but know that that isn't the only form of congruency we have, because look, 9 is congruent to 5 mod 4, right? Is this true? Can everyone tell that's true? Awesome. But you know what else is congruent to 5 mod 4? A lot of other numbers, and actually like infinitely many, because look, 13 is also congruent to 5 mod 4. Can we see why that's true? Okay, because 13 equals to 4, well, it equals to 8 plus 5, which equals to 4 times 2 plus 5. So we have a remainder of 5. And 9 equals to 4 plus 5, which equals to 4 times 1 plus 5. So the remainder in both cases will be 5. So what that actually means is that 13 is not only congruent to 5 mod 4, but to 9 mod 4 as well. And what that means is that when they're divided by 4, they share the same remainder. Does that make sense? Okay, awesome. So I'll just give another example then. Don't have that much space anymore. Let's just say 17 is congruent to 7 mod 5. Do we also see why that's true? Because they share the same remainder when they're divided by 5. So what that means is that 17 equals to 10, equals to 15 plus 2, which equals to 5 times 3 plus 2. So you get a remainder of 2. And then for 7, it equals to 5 plus 2, which equals to 5 times 1 plus 2. So then you get a remainder of 2 in both cases. And that is why they are congruent in mod 5. Okay, does that kind of make sense now? So 17 is going to be congruent to 7 mod 5, which is also going to be congruent to 2 mod 5. So also formalize this a bit more. So a property would just be that if A is congruent to B mod M, and C is congruent to B mod M, then A is congruent to C mod M. So that's essentially what we were doing before, right? We find that they're both congruent to 2 in mode 5, and therefore they're also congruent to each other. Does that make sense, everyone? So they're going to be congruent if they essentially have like the same kind of remainder given a certain modulus. Okay, and then now onto these really important properties. The first one that I'm going to go through is the addition property, this identity. So we have A, B, C, D integers, and M is a positive integer. So let's suppose these are true. If A is congruent to B mod M, so if A and B have the same remainder when divided by M, and C is congruent to D mod M, so C and D also have the same remainder mod M, then you get this principle of addition, which is that A plus C is going to be congruent to B plus D mod M. Okay, so this is just an identity. It's something that you can just memorize and know that it's true. And I think that I can just I think I'll just give an example and then see if we can kind of see how it all works. What does the second M and mod M mean? Like this one. Yeah, that one is the modulus. So it's the thing that you're going to divide, that you're dividing by. Yeah. So for example, you could have like mod 1, mod 2, mod 3, and it's etc. So yeah, M is just like the number that you're dividing by. Okay. Cool. Okay, got that? Nice. Okay, so let's just think of when precisely this will be true. So let's just say, look, we'll just give some examples. So we can just say like 5 is congruent to, how about we say 8 mod 3? And we all know that's true because they have a remainder of 2 when divided by 3. And then we have another congruency, which gives that, let's just say, what should we say? 4 is congruent to 7 mod 3. And also, maybe, just in case you guys aren't so sure, A and B, they are essentially interchangeable. So if A is congruent to B mod M, then B is congruent to A mod M. Okay, just letting you guys know. Okay, so based on what we get here, this identity, can someone tell me what that means in terms of if we plug in these numbers? If we just say like 9 congruent to 15 mod 3. Good job, that's so good. Has anyone else kind of figured it out? So we let 5, Hello?
I don't understand.
Okay, all good. So this is just the thing that I have highlighted in purple is an identity. So this thing is always true. So what I'm just trying to get you guys to do right now is just plug in the numbers. So if we have 5, this one can be A, and then 8, this one can be B, 4 can be C, and then 7 can be D. Then we just want to plug these in to get this identity. So we just want to do A plus C equals is congruent to B plus D in mod M, and in this case M equals to 3 as I've given here, so we have mod 3. So if we just plug those numbers in, right, we just replace A with 5 and C with 4, then we get 5 plus 4 equals to is congruent to 8 plus 7 in mod 3. Then 9 is congruent to 15 in mod 3. Does everyone understand how I've just plugged those numbers in? Okay, cool. And then we see that in the end, this is true, right? Both of them are divisible by 3. They're both congruent to 0 mod 3. So they have the same remainder, which is 0 when divided by 3, and therefore they're congruent to each other. For those of you who are fairly familiar with this, I'll just formalize this a bit more. So let's just say that we're using mod 3. I think it's fine to just suppose that. Then let's just say A equals to 3k plus 3k plus r for remainder. So here, since we know that A and B are congruent, then we know that B equals to like 3j plus r because they have the same remainder. And then now we have C and D with the same ones as well. Or what letters should I use? I'll just use M and N plus this is a really bad choice of letters. I'll just say plus xk. And then D will equal to 3n plus x. Since they're congruent to each other, they share the same remainder. And then what we get from that is that A plus C is going to equal to 3k plus r plus 3j plus r, which is going to be 3 times k plus j plus, wait, sorry, the second one's wrong. It's supposed to be 3m plus x and then plus r plus x. Oh, I'm getting a little tight on space here, but we can survive. And then b plus d would equal to 3j plus r plus 3m plus x. Okay, sure, I'll go through the mod thing again pretty soon, which equals to 3j plus n plus r plus x. And now we note that when you divide both of them by 3, they both have the same remainder, which is r plus x. And that's why they're still going to be congruent. Okay, so I'll just do a quick recap on the mod thing that we learned earlier. So that would just be essentially mod is just given a certain modulus m and a and b, let's just consider the first one, then b is either the remainder when a is divided by m, or when a and b are both divided by m, they share the same remainder. For example, 7 is going to be congruent to 1 mod 2, and 5 is congruent to 1 mod 2. And we know that 5 is going to be congruent to 7 mod 2. Does that make sense? Okay, we can maybe talk through it at our workshops later if you need any help. But for now, how do we know 7 is 1? Oh yeah, so we just want to do like the same thing that I did before, right? So 7 equals to 6 plus 1, which equals to 2 times 3 plus 1. I'll send out a time for the workshop later because I think a couple of tutors will probably just like send out 20-minute slots. So yeah, sometime this week. I just thought that I would leave mine until after our first session so we can ask, relevant questions and stuff. So I'll decide on a time soon and send it out. But the remainder would be 1. So that's how we know that 7 is congruent to 1 mod 2. And also, I think a really simple way of doing mod 2 is you just know that 7 is an odd number. So it must leave a remainder 1 when divided by 2, because odd numbers aren't divisible by 2. So it can't be 0 mod 2. So it can only be 1 mod 2. Okay, cool. If everyone's fine with that, I'll just move on to the second property, which would be subtraction. I think is like the same thing. So is it fine if I just don't go over that? Or do we want to go over that more? Oh, actually, before we move on, how about we just go to, let's just quickly check our progress and then go to the problem 1 in the handout. Does everyone have the handout? It's a pretty short problem. So I'll just write it out anyways. So find the modular for residue of 311. So I chose a pretty big number, but that should not deter us. And also another definition that I'm just going to quickly integrate into here is residue. So residue just refers to the remainder that I've been talking about this whole time. It's just like a pretty common way of saying remainder in modular arithmetic. So instead of, like saying the number that we're dividing by, we say modulus. And instead of saying remainder, we say residue. So essentially what this is asking for is just, what is the remainder when 311 is divided by 4? Can someone just tell me this if anyone has an idea? Okay, yeah, good job, Alina. So expression will be like, yeah, that's right. We can write it like that if you want to. Yeah. Yeah, and M is 4. Good job. Modulo 4 residue. Yeah. So that's just asking for what is the residue of 311 when you consider it in modulo 4. Like 311 is congruent to 3 mod 4. Exactly, yeah. Okay, so I'll just write the working out then. I think it's a pretty big number, so I just need to do the mental maths, but it's 308 plus 3. And we know that we want to find 308 because it's like the kind of the biggest term that is close to 311 that is going to be divisible by 4, which is modulus, right? And then that's going to equal to 4 times 77 plus 3. So then our remainder is 3, which is our residue. and therefore 311 is congruent to 3 mod 4. Does that make sense? Okay. Okay, that's really good. Yeah, it's just basically what we were doing before, but like with a bigger number, I guess. So yeah. Uh, okay, nice. And then I think that we can probably move on to the next problem, which is using the arithmetic identity that the addition identity that I gave before. So this is question 2 in the problem section. So find the units digit of 2599 plus 86 plus 400 plus 3. Okay, look, these are, oh, do we end at 9:30? We end at 9 actually. Yeah. These sessions are all 1 hour ones. Yeah. So you guys can go to bed soon. Okay, what did Jason get? 8? Yeah, good job. So what we're essentially doing, since we don't have much time, I'll just explain it a bit more from now. So I think that intuitively what we do is we just, from our experience, we kind of know that when you add up a bunch of numbers, you only really need to find the units digit. We're only really looking at the last digit, right? Because we know that like the things that are kind of not just the last digit don't really affect the units digit. So what we're actually doing when we do that is considering all of the numbers mod 10, right? For example, 81 is congruent to 1 mod 10, and 72 is congruent to 2 mod 10. So when you take something mod 10, what you're doing is you're essentially like considering the last digit, because you know that like the like the first digit with like the 80 or 70, these will all be divisible by 10. So then we just take everything mod 10. So now we know that 2599 in mod 10 is 9. Then from 86 you get 6. From 400 you get 0, and then from 3 you get 0. So if you add them, or not, why did I, sorry, not quite sure why I wrote 0, but you get 3, clearly. And then you just add them. So since we know that you can just add them up, given the addition identity, you're going to get all of this is congruent to 18 mod 10. Oh, sorry, I don't know why. It's going to be 18 mod 10. And then can anyone tell me what that is congruent to? Yeah, 8 mod 10. And then that would be the units digit. So that's a really good strategy. If something's ever asking you to find the units digit, you can use mod 10 because it's a way to kind of simplify the problem, because the last thing you want to do is add up all of these huge numbers, right? So what we can actually just do is from the very beginning, consider them mod 10 and then find answer at the end, which will also be in mod 10 and hence will be the units digit. Awesome. So I think it looks like our time. Oh, how do I get an 8? Oh, right. So is this referring to the last step where I go from 18 to 8, or is it from?
Yes, from 8.
Right. So 18 and 8, we need to note that they share the same remainder when you divide it by 10. So 18 when you divide it by 10, well, 18 equals to 10 plus 8, which equals to 10 times 1 plus 8. So you know that it has a remainder 8. And this is the same thing for 8, because you know that this equals to 0 plus 8, which equals to 10 times 0 plus 8. So then you get the same remainder, and that's why they're congruent to each other. Is it just the last digit in each number if it's mod 10? Yeah, that's right, because you know that anything that isn't just the last digit will be just, well, divisible by 10 anyway, so we don't need to account for it. For example, like, you know that, say we have a number 57, 57 is going to equal to 50 plus 7, and we know that 7 would be the units digit, but then if you have a number, like the other part of it, like 50, or if you had 507, you had 500 plus 7, then these things are all going to be divisible by 10 anyways. So that's why when we take something mod 10, you get the units digit, because that's the only part that necessarily might not be divisible by 10.